All right, folks, it's back in action here. In this video, we are only going to go through the complex number portion of this page of your notes. In the next video, we will cover the solving quadratics. All right, taking a look at complex numbers, let's first redefine what a complex number is. So a complex number is any number in the form a plus bi, where both a and b are real numbers, but the second portion, this b value is a real number and it has this I on it. So this is called the real portion because there's no I on it. And this is called the imaginary portion of the complex number. Now let's recall that I is equal to the square root of a -1. This idea is what we're going to use to understand this pattern and then take a look at simplifying some things. So if I is the square root of -1 and I square both sides of this little definition, I squared would then equal -1. So when you look at the pattern that I've already filled out for you, you might need to pause to fill this in. I squared both sides, that gave me I squared, and the square root of -1 is -1. So now we know that I squared is -1. Now, where did I get all of the rest of these? We're going to use this to find this pattern. So rewriting, working with our exponents, rewriting I cubed, we can understand that this would be I squared times I. But I squared, we just said, is -1. So -1 times our I is our -I. Then looking at our I to the fourth, again, continuing with our exponent rules, I squared times I squared. Now I have -1 times -1 is +1, which is where this is coming from. Now this I to the fourth, this is going to be the one we're going to use the most to find the remainder of the pattern. So I to the fifth, we're going to start looking for groups of 4. I to the fourth times I. I to the fourth is just 1. That's where the I is coming from. We're going to continue looking for groups of 4. I to the fourth times I squared. Remember, I'm just using my exponent rules. These would add to 6. So the I to the fourth gets to go away. I squared we saw from the beginning is -1. I to the fourth times I cubed. The I to the fourth goes away because it's just a 1. I to the cube, I cubed is back here. There's the -I. Now, when I get to this I to the eighth, I'm going to write it a little differently. Instead of writing I to the fourth times I to the fourth, I'm going to write I to the fourth squared. These two exponents multiply to give us our 8. This idea is what I'll use for the extension. I to the fourth is just 1. 1 squared is 1. So this idea is what we're going to do now here, and we want to be comfortable with this. We're looking for groups of 4. So we always start with a group of 4. How many groups of 4 are in 17? There are 4 of them. So 4 times 4 is 16. I still have an I left over. This part goes away because it's just a 1. So I to the 17th is I. Let's continue that idea. I to the fourth, I'm looking for how many groups of 4 are in 23. That's going to be 5. I'm left with 3 of them. You either rework the I cubed or you remember from back here that I cubed is a -I. Looking at I to the 34th, always looking for those groups of 4. I have 8 groups of 4. That's going to give me 32. I still have 2 left over. This part goes away because it's just a 1, and I squared is a -1. So now, we want to be really comfortable working with these different values. What we're going to see more often than not is a combination of these ideas and these ideas from our Algebra 2. So let's take a look at this simplifying. What we want to notice right away is that I have an I cubed and I have this I squared. Before we try to do anything else, let's get those cleaned up. Let's rewrite this first part. So 15 plus 4I cubed. I cubed is negative I, so this becomes negative 4I. Now the next part, I'm going to write that next binomial. I'm going to keep that in its parentheses for right now. I squared is a negative 1, so this first term inside that binomial becomes a negative 6 plus 7I. Now I can distribute. And now I can combine my like terms. This is going to give me a 21. Combine the imaginary portions, negative 11I, and this would be our final answer. I do want to emphasize that the order matters. I mentioned it up above. I'm going to continue mentioning it. We need to have the real portion first and the imaginary portion second. This is important and it will impact us later in the year. The next one we're going to look at is this fraction. And what we want to notice is first that we don't have any i's that initially need to be cleaned up like we did here or here. The problem with this one is that we have an I in the denominator and we do not leave i's in a denominator. To fix that, we will multiply the top and the bottom by the conjugate of the denominator. That means we're going to change the sign of the imaginary portion. So the top and the bottom gets multiplied by 2 plus 5i. Now, this is not a place where I would suggest trying to do a bunch of things in your head. I would definitely write things out. We are going to FOIL the numerator. So we're going to take that 8 and distribute it. 16 plus 40i. Now we're going to distribute the 3i plus 6i plus 15i squared. When we FOIL the denominator with the conjugate, the middle terms, these two middle terms would cancel, so I only need the 4 and the minus 25i squared. Now I do have some i's that I need to clean up. In the numerator, this 15i squared, I squared's negative 1, so I like to mark that out and rewrite it as a negative 15. And in the denominator, this I squared's a negative 1, but this is minus, so this gets canceled and I rewrite it as a plus 25. Now I can group my terms. I'm going to take my real values. 16 minus 15 leaves me with a 1. I can combine the two imaginary portions. That's going to give me a plus 46i. And my denominator becomes 29. Now what I'm going to do is I'm going to write this as the two separate portions. I'm going to write that twice. If I separate, and that is important, if we separate, we can see the real portion and the imaginary portion, and that is important. Okay, so things that you need to be comfortable with from this video, you need to be comfortable with the idea that the order matters. We always want to separate, and how to simplify these higher powers of the imaginary or these complex numbers.